Students, so today I will be explaining from 2.3.1 to 2.3.5. okay, so in there is 4 or 5 experiments given in your textbook in page number 19 and all. So the first experiment is about evaporation. So you know what is evaporation. So if you want to separate a dye from a solution, so we need to follow this process. So that one is simple, so you know that one. So for that, it is telling that if you want to separate a volatile component from its non-volatile solute, then we can use this evaporation process. Okay, so the condition is like this. So the solute should be non-volatile, so volatile solvent will be vaporizing, so when we are heating. So this is how we are separating or how we are using this evaporation process. Then next case, if we are getting a cream and milk, that means if we want to separate this cream from milk, so we are mixing this cream and milk, so we want to now separate these two solutions. So in that case we cannot use this evaporation technique. Why? Because both the solvent and solute, so both are almost like same properties. Okay, so there we cannot use this property. So instead of that one, we can use centrifugation property. So what is centrifugation? The process by which the particles are separated according to the densities. So the high density or high weight substance will be denser, so that it will be separated down, and the lighter will be separated in the upside, so that we can separate this lighter and heavier particles. So the some applications are given. So where it is used, so it is used in laboratories, then for blood and all. So if you want to separate the blood, means there will be so many components, plasma will be there, RBC, WBC, so many things will be there. So we want to separate according to the density, so that we can separate layer by layer. Then it is also used in dairies, home, to separate butter from cream. So day to day life we are using in our home also for separating butter from cream. Then it is the principle of washing machine, to squeeze out water from wet clothes. So have you seen the washing machine will be rotating? So that principle is by centrifugation. So it is using the rotation, means there will be a centripetal force, so that by using gravitational force this is separating according to their masses. The next one is, how can we separate two immiscible liquids? So this is another case. Okay, so example, immiscible liquids means kerosene and water we can take, or water and oil we can take. So if you are separating, in that case we can use a funnel like this. So automatically if you are mixing oil and a water, what happens is water will be down and oil will be floating above. Here in this figure it's water and kerosene oil, so water is more denser and it will be down, and the kerosene oil will be floating up, so that we can open this lid or stopcock. Then the water will be we can collect the water to this portion, and once the water level is here, then we can stop, so that the remaining portion is kerosene oil. So water we can take and kerosene oil will be remaining in this. Okay, this is how we can separate these kinds of two immiscible liquids. Then in next case, in the case of salt and ammonium chloride, here the case is different. That means both are actually solute, okay, but this one is a volatile solute and this is salt, this is non-volatile, so it is sublimable volatile. That means it will be changing from solid to gas directly. So how we can separate these two things? So once the temperature of this ammonium chloride is increasing, it will be changing its state to gas. So what is happening is, this is a mixture of both ammonium chloride and salt. So once we are heating, the energy it will be it will get, the ammonium chloride and salt will be heating, so that this ammonium chloride will be changing its states from solid to gas, and once it is touching the surface, here they are cooled, so it will be cooling down, and this ammonium chloride will be converting again from solid to gas, from gas to solid. That means once it is heated, it will be changing to gas, and once it is cooled down, gas is changing to its original form, that is solid. Okay, so thus we can collect, and what is remaining will be salt. So ammonium chloride, we can collect from this funnel, and salt will be present here. Or we are keeping this cotton plug here because otherwise the volatile vapor will be escaping through this thing. Okay, so if you are keeping cotton, means in the cotton also the ammonium chloride will be present. Then last one is this one, chromatography technique. That means if you are taking one dye, so if you can observe the color as black or blue, but it's not the components. Okay, so if you are deeply observing, then we can see that there are different particles in that same color dye, or there are different colors in the same color dye. Then how we can separate that? So we are using a chromatography paper here. So this is a chromatography paper, and we are using one solvent. So we are keeping it in a funnel, and we are keeping water. Then we are putting one drop of this dye. Okay, so if you are separating black dye, if you want to separate if you want to know the components of a black dye, we are putting one drop of black dye in this chromatography paper and dipping. So what happens is, after some time, the water rises from its high concentration region to lower concentration region through this paper. So once it is this water or this solvent is touching this ink, then what happens is the diffusion will be taking place. So it will be taking place from this area to the upside. Okay, so along ink is also moving. So we can separate this component. So which is moving faster will be going front, and which is moving slowly, that means according to the dissolution. So if an ink color which is having high dissolution will be moving faster, and which is having low dissolution will be moving slower, and thus we will be getting a band of light. So we can separate the components colors by this process, paper chromatography. Okay, thank you.